For years, we've seen AI dominate the digital realm, writing essays, composing music, generating art. But the physical world? That's been a much tougher challenge. Now, Google DeepMind's Gemini Robotics is taking a leap toward bridging that gap, bringing robots that can not only see and understand, but also act with real-world precision. This is more than just a new robot. It's the merging of vision, language, and intelligence, the foundation for machines that learn like humans, reason like scientists, and move like skilled professionals. The question is, what happens when robots start understanding the world the way we do? The Gemini Revolution, from words to actions. DeepMind's Gemini family of models already redefined what AI can do in reasoning and multimodal understanding. But Gemini Robotics takes that foundation and extends it into the physical world. Think of it as an AI brain connected to a body, capable of perceiving the world through cameras and sensors, understanding tasks through natural language, and then translating that understanding into physical motion. You could say Gemini Robotics is the missing link between ChatGPT and Boston Dynamics, combining intelligence with embodiment. Where most AI stops at describing how to do something, Gemini Robotics actually does it. The goal is simple but revolutionary. Train robots that can handle complex, unpredictable environments with human-like adaptability. Imagine a robot chef that not only follows a recipe but also adjusts when the pot boils over or the ingredients run out. Or a warehouse robot that doesn't just move boxes but reorganizes shelves based on changing priorities, all from verbal instructions. How Gemini sees the world. The secret lies in multimodal perception, the fusion of vision, language, and sensory feedback. Gemini Robotics uses an advanced transformer-based model trained on massive datasets of visual and physical interactions. That means it doesn't just recognize objects, it understands them contextually. When the AI sees a mug, it knows how a human grips it, how full it is, and whether it's safe to pick up from the rim or the handle. When it looks at a messy table, it can infer which items need to be cleared and which should stay. This kind of perception isn't pre-programmed, it's learned. That's a huge shift from traditional robotics, where every motion is scripted and environment-specific. Gemini Robotics learns generalizable physical intuition, a sense of how the world works that can transfer between tasks. In other words, it's starting to think in cause and effect. From simulations to reality training. Robots in the real world is slow, risky, and expensive. So DeepMind did what it does best, used simulated learning environments. Millions of physical interactions, object manipulations, and visual tasks were run in virtual worlds before being tested on real robotic hardware. This approach allows the robot to build what researchers call a world model, an internal understanding of physics, space, and causality. By the time it touches a real object, it's already experienced countless virtual interactions. And when that simulation-trained model meets the real world, it doesn't just execute, it adapts. Drop a cup? It learns the angle of failure. Spill water? It adjusts its grip strength next time. The power of language in motion. One of the most groundbreaking aspects of Gemini Robotics is its use of language as control. Instead of programming a robot with code, you can simply talk to it. Say you're in a lab and you tell the robot, "Clean the table but don't move the microscope." The robot processes that command through Gemini's language model, maps it to visual understanding, identifies the microscope, and executes the task, all autonomously. This language-driven autonomy means robots can finally operate outside rigid workflows. They can collaborate with humans dynamically, understanding context, tone, and even intent. It's not hard to imagine a near future where robotic assistants can handle lab work, manufacturing assembly, or even household chores just by listening. Real-world tests and early success. Early demonstrations show Gemini Robotics performing intricate real-world tasks, sorting objects, cleaning up spills, opening drawers, and handling tools. What's striking is not just precision, but adaptability. When an object shifts slightly out of place or lighting changes, the robot doesn't fail, it recalculates. That's a massive leap in physical intelligence. Most previous robots could only handle narrow, controlled settings. Gemini Robotics thrives in chaos, the kind of messy, unpredictable reality that humans navigate daily. Gemini Robotics marks the next great leap in human-AI collaboration, where intelligence meets embodiment. Robots that see, think, and act are no longer science fiction. They're here. The age of physical AI is just beginning. Subscribe for more insights into the frontier where code comes to life and the world starts to think for itself.